Hey everybody, this is Larry, this is me going with Q4 of the weekly contest 376, apply operations to maximize frequency score. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this one. So this one is very tricky for me. I've seen afterwards, of course, I've seen a easier solution coding wise, but I can't really prove it, or I couldn't really understand the arithmetic part of things, but I'll go over my solution, right? So if you watch Q3, then the idea is that, okay, let's say there's an answer of 5 numbers, right? Well, if there's an answer for 5 numbers, then it's going to be the median 5 numbers of the group, right? So if you have A, B, C, D, E, then it's then you all want to switch the numbers to C because, well, you just code toward the middle because as I did it in Q3, if you choose C plus 1, then of course, then 3 numbers are going to go farther and 2 numbers are closer. So this gives an increased cost. So yeah, you always want the median element for this. And as a result of that, then you can kind of figure out how to do different ways of doing it. But I did it with sliding window. Yeah. And I think based on that principle is the idea. Yeah, so first we sort the numbers, of course. It is a little bit tricky though. It's not just a regular sliding window because of the way that we have to do with the median. And the median can kind of, go left and right a little bit because as you expand. But yeah. And then the hard part is just doing the math as well, right? So, okay. So yeah, so we sort the numbers just so that we can make a window. The best is 1 element, and then we set left and right is equal to 0. So then now this is testing num sub 0 as the best median, right? And basically we just keep on going right and kind of getting it until until we have all the elements we have and then k is gone, right? And then now, and this is of course just to update it. And the idea here is the delta change, right? So here, right minus I elements are to the right of the element, the new element. So all these elements, okay, so yeah, so now we're move median from num sub I minus 1 to num sub I. And that means that all the numbers to the right are closer by delta, and all the numbers to the left are closer by delta as well. Oh, sorry, farther by delta as well. And that's basically how these formulas shake out. And you can kind of just draw it out. If you move right 10 steps, then all the numbers smaller than it will have to move 10 more, but all the numbers bigger than it has to or could move 10 less. And so this is what this formula does. And then now, if k is too much, if now by adding this, by shifting to the right, we have too many elements, we have to remove some from the left, because by definition, if this is the median, then you have too many elements to the left if you have too heavy of a k, right? Otherwise, you want to expand to the left. This only happens when you are unbalanced because you have too many elements to the right, and it happens occasionally because current is not monotonically increasing. There are, I guess, a couple of places where this number, basically you're adding this number and you're subtracting this number, right? And this number can be bigger than this one, right? And in that case, now you have extra space. And basically, yeah, because when this number is bigger than this number, that means that you're right heavy. You have more elements on the right than elements on the left. So yeah. So then that means you can try to expand if you can. And that's basically what this does, is while you keep expanding on the cost, you just move to the left. And then now we have this thing where I do two things, which I guess is a little bit awkward maybe. But basically, while we can expand to the right, we expand to the right, straightforward. You know, if we can add the number to the right with I as the current median, then we just add it. And this one is if we can go to the right by, or if expanding to the next number is optimal because basically if expanding to it is, you know, if you add the next number is too big, but it's not too big if you swap that number with the number to the left, meaning that, you know, you push left forward and then you also push right forward, so you're moving the entire window one at once, then now you win some delta back. And that's basically the idea, is that, you know, in a greedy kind of way, and that's what this does. Yeah, and then at the end we just kind of check again, and that's pretty much it. This is going to be O of n log n because of the sorting, but everything else is O of n. I think the part that is a little bit confusing is because we do expand to the left, so how do you say this is O of n? Well, we only expand to the left if we also expand to the right, and to the right we only go O of n times, so to the left you only go O of n as well, because we always want num sub I to be the median number. And that's basically the idea. I probably could have written this in a cleaner way, to be honest, if we treat I as a median number, but there is some like weird edge case with treating it as like the median number, but like of a even length sequence, and that's a little bit confusing. The code is right. It's not. I'm not happy about it, to be honest, but hopefully the ideas and at least this proof of concept allow you to kind of expand on it and play on it. I've been up. I'm still very jet lagged, so I am going to pass out. So definitely ask me questions here or on Discord, and we'll get back to you. But yeah, this is definitely a very hard problem. It took me longer than, it just took me a long time. So yeah, let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye. Oh wait, yeah, and well, you can actually watch the live portion of this next. That's how jet lagged I am. Okay, it's okay. Okay. Maybe I could have submitted that earlier. I don't know. That one's kind of hard to prove for me. I think it's just around median. All right, let's focus on this one and we'll chat later. Choose any index I from the way and increase and decrease numbers by one I by one. The score is a final way of it. Okay, so yeah, you could do k things. And it's the frequency of the most frequent thing. Okay. The English part seems okay. Between the two. Is this I mean, there probably is like a scan line thing, right? K is big though, but no. Does it always have to be the original? Do we always want it, or do the answer always have to be in the original way? I think is what I'm trying to get at. I don't think so. Do you always want the median? Not necessarily. Does it always have to be one of the numbers? The answer may be yes, maybe. Because by definition, if it's not one of the numbers, and you can move it to the left or to the right and still have the same thing. Kind of same with the median finding issue. Though I don't know with the K constraint whether that could be done. Can we binary search on each number? Resort, heap. Is there a case where the original number is not I don't think so, but maybe I'm wrong. Because if they're odd, yeah, no, it's basically the same with the median argument. So basically, let's say you have a number, and you want to so is this just sliding windows? In two directions? How do we do the greedy? This is in two directions. So every time you add a number, what does that mean? How am I doing on time? An hour 8? Not that bad, surprisingly. I spent so long in Q3 on proofs, but people have gone Q4 though, including Josh. No surprise there, but it's kind of like the median algorithm, but I have to figure out how to do it. It's like sliding window, but median. No, does that work? We did get it pretty quickly though. It feels very median-y, but can we do sliding window on the number of elements? Can we binary search on the number of elements? Binary search, and then you do a linear. How do you do a binary search? Number of elements in the final answer. Do a sliding window. With the rolling median. Keeping track of the median of the number and the thing and the thing. Is that even remotely fast enough? The rolling median is n log n, another log n, and it's pretty big though. I don't know if you could do that many log n's. So we use 2 heaps. Is this just sliding window? Yeah, I guess maybe just sliding window. Right. Oh my god, they're both max heaps for some reason, right? No, we want the min heap from the right. Right, so then now no, that's not right. Okay, so this is sorted, I remember. Let's say you put everything in the beginning. If it's a min heap, it doesn't matter. You don't need a min heap. It's an order. Always pop to left, and then what? Cause a movement review. No, this doesn't work. How do you decide whether you want to add a new thing or remove a thing? No, it's pretty straightforward. It's linear. You just do the math. Okay. Yeah, I think I'm a little bit slow on this one. I don't know. I'm struggling a little bit. I don't think this is that bad, but okay, fine. Okay. And then left. Okay, right. I guess I don't know why I'm blanking on this one. This is not that bad. Okay, so that's the initial thing. Is this right? Why did I return 3? 1 plus 3, this is wrong. Right? Because you can't connect 1, 2, and 4 by 1. Oh, I'm dumb. So that's 1 and 0 and 2. So 2, okay, so this is the next number, I guess, and it's not inclusive the way that I did it. Okay. And then now, to get the next number, okay, now basically we want to move, we want to do I, and what this means is that okay, delta is equal to numbers of I minus okay, and then all the numbers to the right, so something like y minus I now this is subtracting to the left. I'm like so bad at math today in my head, so that's why I'm printing out everything. Is this right? Kind of. I'm doing it in a weird way, that's why. So So the 2, it is still 1. Okay. But then now we want to see if we want to add so the invariant is that current is less than or equal to k, and then we want to add if okay, so while current is greater than k, we have to move away from the left. That's for sure, no matter what. So okay, what? That's probably not quite right, but oh wait, this is just really wrong. Whoops. Okay, that looks better, at least for this part. This part not so much, but that's okay. Okay. So because we only remove, so that's probably why. The 2 is going to be 0 and 2. So just these 2 numbers, but we actually want to also have the 4, because basically, okay, so let's say we got out. And then now we while we swap, so it's the exchange argument. Well, if we get it for free, then we don't need to. Right? No, it's not this, it's this minus num sub I. What should I turn out to be like just really wrong? But people got it so quickly. And this is a textbook problem. I don't know how people do it. 3, but I don't think this is. I guess that's fine. Well, the question is, can you swap things in? All right. This minus. Also, this is just wrong. This is this minus num sub I. Oh, the other way around. So definitely just very lucky with these cases. And then I can rewrite this in a little bit better way. Yeah, so if this number is smaller than this number, then yeah, let's roll forward. Technically, I want this before. Oh, I keep writing that. Okay. Equals 0, I guess that's right. 2 and 5. It's 0, 1, 2, and 5. I guess that's right. Am I right though? I feel like this is not right, to be honest. It feels very I need like... Okay, for 0, this should be 6. Okay, that's true. Now what if we change this to 1? Should be 7. Okay, fine. Where is 2? 8. Okay, fine. I'm gonna submit. I'm not confident about it at all, but I think a wrong answer is worth 5 minutes. Okay. And now we can debug it, because I don't know if I could come up with a reasonable answer in 5 minutes and be right about it. Okay, so the answer is 7, or we expect 8, but my answer is 7. Why is that? I definitely do things in a really weird way. I don't know which way is more optimal. In the swapping, in the greediness. So we swap, but we don't need to swap unless this is the case yet. Okay, maybe that was it. Maybe that, or because we keep on adding things. Okay, fine. Alright, let's give it a YOLO submit. Maybe I should have done that loop thing. I wasn't sure. Ooh. This index. Oh man, how did I do this? Line 12. Yeah, I did it in the wrong order. That was a very beginner mistake. Alright, I'm still not sure this is right. Okay, yeah. But that definitely made it a lot harder to be fun. Is it not greedy? I have 14, the answer should be 15. This is 77. What is the answer? Okay, so for 4, probably less, but okay, 12. 14, 14, 14 to 0 to 12. 77? How did I get 77? At least this guy is consistent, which is good. Let me do just as a, oh no, it's not that, it's what was this? Minus numbers of I times like minus left, I guess. Well, maybe that's a formula we can use. That's the number of cell things, right? Oh, I guess it's the difference. Okay, fine. Maybe not. This is just for debugging. Man. But also, honestly, I don't know this one, so it's not like I'm making silly mistakes per se. I just don't know. Well, some of them are silly, but it's not just that. Okay, so I just want to verify that this is true. But is either that or the answer is a number that is 14 and between 14 and 20? I don't know. Maybe that is the thing, I don't know. Because I think for these numbers, that should be right. Maybe. So this adds 15. That is clearly too much. Fine. I'll write something even more proof for us. Because I want to verify that what I'm thinking is right. I'm lazy. So 4 and 1 is 1, and 12. This seems to match up. So that means to suggest that the answer is in here, maybe. So for example, which is one of my wrong assumptions, I guess. And what are the constraints? Let's just do 30. What? So there's the 15. Is 21, which is not. Oh, it is part of the answer. What? Hmm. 21 is 0, 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12. Okay, I see. So it's all of these, but I could still squeeze in this one, but somehow it dropped off with 20. Is that true? So 20 went from 3 to 17, and then 20. If and that is a tricky one. Oh, I left in my debugging code. Whoops. Some days. Oh, well, I left in my debugging code anyway, so that would have been failed, but that is most unfortunate still. And I have some printing statements still. So I have 15, but it should be 16. 16 is... I am doing some greedy wrong, am I? Where's the input? 104, okay. So we want the answer to be 18, 19, 18. From 1 to 16, so 1, 2, 3, 4, 5, 6, 7. But it has room for 4. Why did we remove the 4? When did this happen? Oh. Because this 15 can only go from 0 to 15. Or whatever it is. And then when the 17 come along, that doesn't make sense, does it? Some British. How much time do I have left? 36 minutes. Oh, so 17 greedily added. Wait, what? What is that total up there? This swapping thing maybe is not, it's nonsense. Do we even need it? Am I just like creating nothing for no reason? I thought I needed it. Yeah, I do needed it for this one. Or something of it. So this is 94. We optimized to go to 93 because this is 13. But I guess we didn't assume that in the future this can go lower. So maybe the sliding window is a little bit wrong. Because for 18, now we can add back the 4. Even for the set. No, yeah. So this one we can. I guess we can always just keep on doing this while, right? I don't know, this just feels like a hack, to be honest. Stuff is already in it, right? So I feel like this just feels sketch. Like there's no way this is right, but I'm just YOLOing. At this point, I have some output, but I don't think it matters. I don't get it though. Like, I mean, I'm glad I didn't do it because I had like 4 wrong answers. That's a really hard one. I don't know if I understand it. I guess that's the problem with greedy problems. Well, I mean, I understand it. It's just more like, is there a way to prove complexity? Well, I mean, as you move from left to right, like I feel like there's a way you can just go back and forth, and maybe that's just like, maybe it's not actually possible. Because the right always goes right, so that's fine. But I cannot prove that left is going to be linear, right? Like, is there a case in which like like the input that we had, what if we just keep on adding more numbers? Then it would go back to the right. Would we ever go back to the left? Do we ever yo-yo? So I guess that only happens when we are right heavy. As if we sort of this, because we still kind of want the median. And because we want the answer to be the median, like all these numbers are the median of the thingies, right? Roughly speaking, I mean, I guess there's some like duplicate stuff, but well, I mean, like I said, there's some edge cases with duplicates, and also like just apart from the edge, like here it's just unbalanced because that's literally the entire array. But otherwise, you want everything to be the median. Is that right? I mean, I guess you can do the same thing, but maybe with just like 20 or something. Do you want the median? Well, assuming that this is the middle number, then I guess you don't always need it to be the median, do you? Because you could just be like very heavily on one side. I don't even know if this is right. I mean, this passes the cases, but it may be one of those things that fails afterwards. No, you always want the median, or it may be unbalanced. I mean, it doesn't always have to be the median of the entire array. It has to be the median of that portion. It's going because by definition, if you have the same length and is unbalanced, then you always want the median. And as a result, if you always want the median, because every time you go right, you only go left once. And it's that case, then now you're bounded by linear. Yeah, the optimal answers are always where the median, or where it is the median, right? Because if this has 9 and 7, well, I mean, this is a duplicate case, which is different, but let's say 9 and 6. And just by definition, you make this sum smaller, I mean, even this says a smaller array, so it's a little bit different, but you can make it a little bit more optimal by moving to one side. So the answer is always going to be a median of the local arrays. Like this one, it is 7 and 8. Because even in a very unbalanced side, like even on this one, it's just basically there's a median version, right? Also, I think I off by one of these fit either way. Yeah, okay. I think if you believe in the median thing, which I don't have a strict proof for, then this is linear because by definition of median, for every time you expand this to the right, you can only expand this to the left once. So then this is, so it doesn't yo-yo in that way, and then yeah, this is linear time sliding windows, though it's a very hard proof for sure. That's what I think that's what I have for the contest portion. Yeah, let me know what you think. Any shout outs? I'm a little bit late. Yeah, thanks everybody. Thanks for watching. Stay good, stay healthy, to your mental health. I'll see y'all later and take care. Happy holidays. See you later. Bye bye.